In this video, we will take a look at EIGRP. The diagram that we have is just like what we had before for RIP, but I threw in some of the descriptors showing the IP of the interfaces just for clarity's sake. So just like RIP, we're going to go into each of the routers and we're going to input some configuration information for EIGRP, and as we do that, we're going to see that each of the routers learn the routing statements to other networks. So we're on our first router, router 0. We're going to config, and just like we did router RIP, we're going to do router EIGRP, but then we have to give it what's called an autonomous system number. So I'm just going to go with 1, and just like RIP, I want to tell it what networks are on this device. And the next part that I have to use is what's called a wildcard mask. It's kind of, I almost think of it as the opposite of a subnet mask. So typically where you'd have the 255s, you'd put in a 0, and where you have the zeros, you put in the 255. So we did find it for the 0 network, and now we'll define it for the 1 network. I think that's what we have on that one. Let's pull this over. No, the 10 network. Okay. Now we'll go to router number 1 and do the same thing. And we are on 0 and 1 on this one, yep. Now, right when I hit this, I'm probably going to get some messages up on the screen, up on the console there, tell me it found a established adjacency with a neighbor. And there we go. This is it. It's basically telling us at this point in time it's discovering the other device over there. So now we're going to go ahead and add the 1 network. Now it didn't give us that message because our other router, router 2, has not been configured. But once we get that router configured, we're going to get a very similar message. So you see, once we put that in, we got that new adjacency. Okay. So now we have our route statements on all of our devices. So now if I do a show IP route, we're going to start to see what it's learned. So the D is what is EIGRP. The D, obviously there's no D in EIGRP. The D comes from dual, which is the underlying component of EIGRP. So we've learned about the .0 network. We've learned about the .10 network. So let's just close that out. So we've learned about the 10 network over here and the 0 network. Go on this one. In this case, we have learned about the .1 network, the .2 network, and the .20 network. So all those are over on this side. So now from this device right here, our PC at 10.10, let's go ahead and ping the 2.10. And there's our replies. So now our device from over here knows the correct path all the way to this one. Now, let's take a look at if we add another connection between these two devices, but we'll add it as a serial connection, which is going to be slower than Ethernet. And let's just kind of see how that works. So let me drag this down so we have a little room. And I don't have to go into each of these devices. I want to, well, first off, let me make sure and save the configuration. I want to go in. I want to turn it off. I'm now going to add a serial card. I'm going to go ahead and turn it on. I'm going to go to the other device. I want to save the configuration. I'm going to physically turn it off. Add a serial card. Turn it back on. Now I'll go back to the original device. And just to make it easy, we're just going to go in here and add an IP through this. So we're going to give this 10.0.0.1, 255.255.255.0. And we'll come over to this one. And we will give this one a 10.0.0.2. Now we will connect these two from serial 0 to this serial 0. Now we can see the ports on the serial 0 came up. No, you're going to CLI. And I can ping 10.0.0.2, which is its neighbor. Now what I want to do is if I do my IP route, I have nothing about getting to any of the other networks via the 10 network. So what we're going to do is just provide some redundancy. So we're going to have this serial link through here. Again, this is slower than this Ethernet link. So by default, packets from here that are destined for here, for this PC, are going to take this path down through here, up, and over. But this is providing redundancy in case any of these links right here go down. So that's actually what we're going to do. We're going to shut down one of these two, and we're going to see how the traffic will now flow through this path instead of this way. So let's get in here. And we're going to add the network of 10.0.0.0 with 0.0.0.255. And do the same over here. And we'll see we get a new adjacency on that as well. Alright. So let us go ahead and let's see here. Let's just go ahead and do this. Alright, so let's go ahead and open the terminal here, and let's go ahead and ping 192.1. Let's put in the -T for 192.168.2.10. Alright, there we go. So now it's learned its route. Okay, so it's going. Now let's go ahead and, fortunately I think you're not going to see this, but let's go ahead and do a shutdown. And we'll do a shutdown. Okay, so that just went down. If we pull our PC back up, we see we're still successfully pinging. And that's because it's no longer going this route, but instead it's now going this route. So let's see if we have a better way of showing this. And we'll try that through the simulation mode. So let's get back in here and do a no shut. Actually, let me just go back into there. Now if we go over here from real time over to simulation, let me go ahead and delete everything that's there. And so let us add a simple PDU from this device over to this device. And we will play this one step at a time. Let's move this over so you get a better view. There we go. So here we go. We're watching a packet jump from the first PC to the switch, from the switch to the router, and then from this router down to this router, and then from this router to that one, to the switch, to the PC, and now it's gonna come back. So now let's make a failure in here. So now this interface is shut down. So now let's see what happens when we run this packet from this PC over to here. So at this point everything's like it was before. Now what's it going to do? So now you see it comes across here because this is no longer a viable pathway. Down, and then it takes the same trip back. Okay, so it does that because the routing protocol, when you had both links up, routing protocol saw this as the preferred route. But once we brought this down, then this became the preferred route. So that's about it. Again, configuring EIGRP, at least the very basics of it, very similar to RIP. And just like with RIP would have done the same thing if we did this scenario with multiple paths. But we just showed it here in EIGRP. So hopefully we'll get into a little bit more complex EIGRP before the competition, but not sure if we'll have time for that. All right, thanks guys.